Hi, good morning, Algebra 1. This is 11.5. We are adding and subtracting rational expressions. So go ahead and date and title your notes. It is Wednesday, 4/22, 11.5. Adding and subtracting rational expressions. Open your book to page 473. And I've got this example here. We've got two fractions that we're asked to add, but they have different denominators. And that's going to be the situation of this section. What do we do when we have to add two things that have two different denominators, or even one doesn't have a denominator? And we'll see different things. There's one variable in the denominator here. We'll see you could have a variable in any of the spots. It could be in all four spots there. So let's give this one a try. All we have to do is apply what you just learned yesterday in 11.4. And 11.4, we learned to find what we called the LCM, the least common multiple. This is 11.4, least common multiple, and we went through, we added multiples, 6 times 4 gave us 24, 8 times 3 gave us 24. They also both have a multiple of 48, and then they still have more pairs of common multiples later on, but we want the least one, so we just stop and we stay with 24 as our least common. And then we said, well, hey, what if we throw in some variables and just make sure that you pick the least number of factors needed to cover all of the expression. So there's 5 b's here, but only 1 b here, so you have to pick all 5 b's. Right, so you end up picking the higher exponent on the variable, so b to the 5th versus b to the 1, you have to pick b to the 5th. A squared, a cubed, pick a cubed. You need the least number to cover all the expression. And if you have one in one but not the other, like c, you just pick c to the 1. You have to add that c on there once. All of our factors, final answer for that example. Okay? So that was yesterday's, and we're going to apply that here. Both situations there. So that's our least common multiple is the 12x. Now, we can use this. So how do you get to 12? How does 6 get to 12? Or how does 6x rather get to 12? 6x, if you multiply it by 2, you get to 12. How does 4 become 12x? Well, you multiply it by 3 and an x. So let's do that for both of our numbers. You're writing all this down into your notes. Okay, so there we go. 7 over 6x times 2 over 2 plus 3/4 times 3x over 3x. Remember, we can do that on an expression because that is equal to 1, and you're allowed to multiply anything by 1. We get 14 over 12x plus 9x over 12x. And now that those have common denominators, we can add the numerators together. Careful, they're not like terms, so we're just going to put a plus sign and keep them together in the same numerator. Okay? And there's nothing to reduce. We can't. We're done. Okay, so you can pause here if you do need to still get any of that into your notes now. Now, we found a least common multiple, okay? 12x was a least common multiple, but now we see that least common multiple is occurring in both denominators. So it's a special case of least common multiples. So when you see a least common multiple in both denominators, we can now change the name and call it a least common denominator. So our least common denominator is 12x. So we have least common denominator. Okay, and we have a blue definition box for ourselves on page 473. So make sure you're in your book on 473. It says least common denominator, LCD. The least common denominator, LCD, of two fractions is the LCM of the two denominators. Okay. Let's go ahead and flip over a page to 374, and we're going to work through example number 1 on page 374. We're asked to do the addition of 5 over 3x plus 9 over 4x. Okay, so there's our example. This is on page 474. Copy that down into your notes. I'm going to look for the least common multiples here. So I've got a 3 and a 4, and I can go back to my list that you guys copied down yesterday. If you guys ever are in question or don't want to come up with them again in your head, you have the list of the multiples. So I can go to my list of the 3s and the 4s and copy those, start copying those down, or even just flip back to this list and start scanning across. Okay, where do they start to have something in common? Oh, they both have a 12 right there. Okay, further down, they both have a 24 in common, but we want the one that occurs least, or the one that occurs first. They even have another 36 be another they have in common there. So we want the one that occurs first, so 12 would be the least common denominator of all the common denominators they have. So our LCD is going to be 12, and then 3x and 4x, they each have one x, so I need to have an x in my LCD. So LCD is going to be a 12x, and then just like the last problem, we're going to find out what each denominator needs to be multiplied by to get to 12x. So over at 3x, 3x times what will give me 12x? 4. So we're going to multiply this fraction by 4 over 4. Copy your plus sign. And our next denominator is 4x. So what times 4x will bring me to a 12x? Well, 3 times 4x gives me 12x. Or you can go the other way and divide. You could say 12x divided by 4x leaves me with what? 12x divided by 4x is 3. 2 avenues to get your number. Multiply by 3 over 3. Okay, hopefully you wrote this down. You are left with 20 over 12x and a 27 over 12x. That comes from the 5 times 4 and the 9 times 3, right? Denominators stay the same. Since we multiplied, right? We multiplied our fraction straight across the top of the fraction, straight across the bottom of the fraction, and now we're going to do the addition, right? So when we add, the denominators stay the same, and we add the numerators. So 20 plus 27 gets added, and you keep the same denominator. Okay, and we have 47 over 12x. 27 over 12x. And you just double check, can I reduce it from here? And you can't, there's no simplification. You can just leave it as 47 over 12x. And don't put it in your calculator. We don't want this as a decimal. I want a fraction, which is more accurate. Simplified fractions is how I want your answers. Okay? All right, let's take it up one more notch, and we're going to do example 2, and this comes also on page 474. So example 2, we are subtracting, and I'm giving you binomials. Subtract binomials in the denominator. So we have 5x on top, x minus y, subtract there, and we have an x minus y. Okay. So looking at this, what is our least common denominator? Well, I want you to think of each of those denominators, each of those binomials as a binomial, as a unit, as a thing with, like, maybe even you can think of it as imaginary parentheses around the outside of it, okay? So that's the denominator for each of those. Do you notice they're exactly the same? So when you're comparing LCD, the least common denominator, well, they each have an x minus y once, so they already have a matching pair of factors. It's the x minus y, so we don't have to change anything. It already has common denominators for us. So our LCD is x minus y, that's already done. Now we can just subtract the numerators as the sign shows us. Okay, so I've written my 5x minus 5y in the numerator, and I've written it with the same denominator because they're the same. And we're gonna, we were done at this point in the last problem, but we want to see if we can simplify. Is there anything we can simplify? Take a look. Anything we see? I see a greatest common factor in the numerator. You see that? We can take a 5 out of both terms in the numerator. Go ahead and take that greatest common factor out of the numerator, and that 5 gets multiplied on the outside of whatever's left. Denominator stays the same. So when I took out the 5, that was a 5x. I'm left with an x. Copy the minus sign. I took out the 5 from the 5y. I'm left with the y. Okay? And I can always double check my work. If I were to distribute the 5 to both of those terms, I would end up back with that original, or the previous step. And now that I look at this, I ask myself again, can I simplify in any way? And if you look, remember we said the denominator is kind of like, there's like parentheses around the denominator also. I'm going to add those back in. Now I have those parentheses back in. You see something? A pair, okay? We have a pair that's the same thing, and it's multiplied on the 5, so we're allowed to take that pair and cancel our vocab here. So that cancels, we're going to cancel that, and it becomes a 1, because anything over itself is 1. 1 over 1 is 1. 5 over 5 is 1. X minus y over x minus y is 1. 1 million over 1 million is 1. Okay, so we get to cancel those two matching terms, one in the top, one in the bottom, to a 1. What is left after that? Well, I have a 5 times the 1 over 1. And you guys know you don't really need those ones. You don't need those ones, and you get just a 5 in the numerator. And that is your answer. Okay, if you need to pause here and finish copying those notes, you may do that now. We're going to try another example here. We're asked to add two fractions, and there's a bunch of binomials in them. So this is example 3. We're still on page 474. So you are asked to add, we have an x plus 3 all over an x minus 7. You're adding that to an x minus 2 all over an x minus 1. Copy that into your notes. So first step, we need to find our least common denominator, right? It's a least common multiple that occurs in both denominators. So what would I have to do to find my two common denominators? Well, I'm looking at each of those denominators and what occurs in them. Well, I have an x minus 7, and if it helps you, you can put little parentheses around those binomials. So I don't want you to try and do anything crazy like think you can cancel the x's. You cannot cancel those x's. That's a binomial. That x is not multiplied onto the 3 and the 7 and the 2 and the 1. It's added or subtracted, okay? So do not cancel x's here. So we have to cancel the whole term, the whole binomial there. So we have an x minus 7 and an x plus 1. So when I'm determining my least common denominator, I'm going to have to take one from each. This is just like when we had that c term in our example yesterday. One of them had a c and the other one didn't, so we had to include c. Well, in this one of them has an x minus 7 and the other doesn't, so we have to include it. And then one of them has an x minus 1 and the other one doesn't, so we have to include it. Okay, so that's our least common denominator there. And to get to that, well, this one needs to be multiplied by an x minus 1 over an x minus 1. And this one, this fraction, needs to be multiplied by an x minus 7 over an x minus 7. And that'll allow both denominators to have this LCD. So go ahead and do that multiplication now. Okay, check that you have that. And we're now going to distribute, or since it's 2 binomials times 2 binomials, we use the trick of foiling. So now you're going to FOIL each of those 4 things, right? We've got the numerator on the left and the numerator on the right, and you've got the denominator on the left and the denominator on the right. So let's go ahead and FOIL all 4 of those in your next line. Here's my progress. I've FOILed F-O-I-L, and now I need to combine my middle terms, my outside and my inside for each of those 4 FOILings. I'll do that as my next line. Okay, so I've FOILed and then I've simplified, combined like terms, and I can see that I now have 2 denominators that are exactly the same. We both have the quadratics of x squared plus 8x plus 7 in the denominators there. And so just like what we did before, when we had the same denominator, we got to write it once, and we add or subtract what is in the numerator there. So let's do that now. So rewrite the denominator once. We're adding everything in the numerator. Oops. Okay. So check yours against this. If you need to pause and you haven't finished to this step yet, go ahead and pause and make sure you can get this and have that on your paper. Okay, so I've added, there's a plus sign right there for adding these 2 quadratics. And now I have some like terms that I need to combine. There's an x squared and there's an x squared. There's a 2x and there's a negative 9x. There's a minus 3 and a plus 14. So let's combine like terms. X squared plus x squared, that's like a 1x squared plus a 1x squared, so you're left with 2x squared. We have a minus 9x plus 2x. We have a minus 7x. And there's a 14 minus 3, so we have an 11. All over that same quadratic denominator. Okay, and that is our final answer. Okay, if you need to pause this and get any of that down into your notes, you can do that now. Okay, and we're going to do one last example of these together. So this is example 4. We're finally flipping the page now, going over to page 475. We're going to do example 4. And this one we are subtracting. Subtract, we're going to handle it like the last one, except we're going to subtract, which we just have to remember. The key tip here is just to distribute that subtraction sign when you're ready to do your subtracting. So we have an x plus 5 over x plus 6, and we're subtracting x minus 2 from an x plus 4. So write that given expression down into your notes. Make sure you have this whole thing. And I'm going to look at what is my least common denominator. Well, if it helps you, wrap all those binomials in parentheses. I have an x plus 6 in one, and I don't have that in the other. So I need to have that written once, at least once, to have it be a common denominator or a common multiple, and just once because we need the least, the fewest number it occurs, but enough to cover it in both situations. So I need one parenthesis of x plus 6. And now I also need an x plus 4, so I can, because the other denominator has that one, but not the first one, so I have to include it once. Okay, and that is my least common denominator there. That's my least common denominator. Now I have to multiply the first one, with an x plus 6 in the bottom. This fraction has to be multiplied by x plus 4 over x plus 4. And this fraction has to be multiplied by an x plus 6 over an x plus 6. That way we can get the least common denominator, something that is the same. So go ahead and do that onto your papers now. Copy that subtraction sign. Okay. And even if there aren't parentheses or you don't have them, you have to understand that even if you don't see the parentheses, you know they're there, okay? You don't have to draw them, but you have to know they are there, okay? You can't do anything crazy like multiply that, you know, the 5 and the x there and then just add the x and the 4 or something crazy. There's a parenthesis. It's this whole binomial times that whole binomial, okay? So I've added parentheses there. Now we FOIL in all 4 of those spots. Go ahead and do that now. Okay, so I FOILed both the numerators and the denominators, and now I need to simplify. I need to combine my like terms. That was the outside and inside terms of FOIL. Those need to be combined, so I'm going to rewrite this for the next line. Okay, go ahead and check yours. If you still need time, hit pause, finish this on your own, and then check it against here. Okay, now we're going to rewrite it with one denominator that is the same, but I want you to be really careful about this minus sign. What are you subtracting? What does that minus sign tell you to do? Here's 2 options. Does the minus sign tell you to subtract the x squared only? Or does the minus sign tell you to subtract this entire fraction on the right? It's your second option. You are subtracting everything, right? Here's your subtraction sign. It's not just given to the one little variable up there. You're subtracting the whole fraction, the whole thing. So what that means is that subtraction sign needs to be distributed to each of the 3 terms in your quadratic in the numerator. So that minus sign needs to be distributed to each of those 3 terms in the numerator. Now when I rewrite it, I'm going to write it as a minus x squared minus 4x plus 12. Minus a negative 12 is a plus 12. So go ahead and rewrite it with the distributed negative sign. First quadratic stays the same, x squared plus 9x plus 20. That's not changed. That's what you're starting with. Then you're taking away this next quadratic. So take away x squared, take away that positive 4x, take away the negative 12, which makes it a plus 12. Okay, and that is the same denominator now. Go ahead and check that work. All right, and now we can combine our like terms. So be careful, we've got some funky things happening. We have a x squared and a minus x squared. Last time we added them and got 2x squared. Well, now it's 1x squared minus x squared. So those are going to be gone and cancel to a 0x squared. So we don't even have to write them. And then we have a 9x, a positive 9x with a minus 4x. So that positive 9x is you're subtracting a 4x, and that is 9 minus 4, so you have 5x. So we can write that. That's the first thing we'll write in our new final answer numerator. So you have a 5x. And then lastly, we have a plus 20 and a plus 12 in the numerators there. So 20 plus 12 gives us a 32. Write that into your numerator. And then we have just the same denominator that was there from before, so copy that same denominator. Okay, and we are done. You would ask yourself, is there a greatest common factor? Are there any pairs? Is there anything that I can take out now? Maybe there was a GCF in these two numbers, and then you could factor this and cancel another binomial, but you're done here in this for now. You're not going to take this a next step. You can box your answer. There's no more simplifying that you can do to this. Okay, and that is your final answer. This is example 4 on page 475. You can pause this here if you do still need to copy that down. All right, the homework and more information will be in Ren Web, and I'll see you tomorrow.